Hi guys, this is Louisa and Anna's final exam project. The concept that is showcased in our demo is Boyle's Law. Boyle's Law is a relationship between pressure and volume relating to gases. This is the equation for Boyle's Law. P1 V1 is equal to P2 V2. As the initials are multiplied together, they'll give you the final. Another thing you guys should know is pressure is equal to force over area. This demonstrates the inverse relationship. Because area is in the denominator, when it increases, the pressure decreases. One of our first examples is a balloon flying up into the atmosphere. As the balloon gains elevation, the atmospheric pressure decreases, and therefore the overall volume of the balloon increases. Robert Boyle was the scientist who discovered the relationship between pressure and volume, hence the name Boyle's Law. He used J-tubes in order to test his hypothesis pertaining to the inverse relationship. In his J-tubes, he added pressure into the J-tubes, and he tested how much of a volume change occurred. So when he added 1 atmosphere of pressure, doubling the pressure, he noticed that the volume decreased by 1/2. Our second example pertaining to Boyle's Law is a basic syringe. There is liquid outside of the syringe, and when the plunger is pulled back, the volume inside the syringe increases. Therefore, the pressure decreases and a vacuum is created. Therefore, it sucks the liquid up into the syringe.
The ideal gas law also plays an important part in our demo. The ideal gas law describes gases whose pressures, volumes, and temperature relationships are described by the ideal gas equation, which is PV equals nRT. There are a couple assumptions that we have to keep in mind when using the ideal gas law. The first assumption is that molecules of an ideal gas do not interact with each other. The second assumption to think about is that the combined volume of the molecules is much smaller than the volume that the gas occupies. In the ideal gas equation, the P stands for pressure, the V stands for volume, the N stands for the moles of gas, the R is the universal gas constant, and T stands for temperature. When doing our demo, you will see that the carbon dioxide inside the bottle flows downwards and outwards from the bottle. This is due to the fact that carbon dioxide is more dense than the air. Sodium bicarbonate, or baking soda, is alkaline, meaning it is basic. Vinegar is acid-based, so when the two are mixed together, the result is water, sodium acetate, and carbon dioxide. When you use the cork to close the bottle, the carbon dioxide cannot escape from the bottle. As the moles of gas produced increases in the bottle, the pressure inside the bottle also increases. Therefore, the cork is exploded out of the bottle due to the large increase in pressure, and it can no longer contain the gas inside.
These are the materials that we used. First, we needed a 500 milliliter soda bottle. Ours is actually just a plain old water bottle. We needed a cork to stop the gas from escaping the bottle. Baking soda was one of the reactants in our equation. It was one of the things we added to the bottle to make the reaction occur. We also needed 1 molar vinegar, which was also one of our reactants in our equation. We also had a few safety guidelines to follow when performing our experiment. We made sure not to point the bottle or cork near anyone's eyes. We made sure to stand back and away from the bottle. It's also really important to wear goggles during this experiment. You'll notice that in our video we are not wearing goggles because we weren't in school, but definitely wear goggles. Lastly, the bottle used for the demo should not be used more than twice.
And finally, here's our demo.